Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. It's me again, Teacher Kent. And today, we're going to understand more about forces. I've actually downloaded a PowerPoint presentation to help us understand more about forces and how we are going or how we are currently using forces in our day-to-day lives. Are you ready to learn? I hope you are because we are going to start right now. So let me just share my screen with you. Here you are. These are examples of forces. The first is the magnet. There is a force of magnets that actually attracts metals towards it, okay? Even if it's not directly touching the metals, those metal parts will go towards the magnet, okay? That is an example of a force. Next, the person trying to lift weights. Yes, the skinny person is trying to lift heavy weights. He's trying to exert his own force to actually carry the heavy weights. Now, let's go to the next one. What is force? I think we've already talked about this last time on my last video and on our online class. A force is either a push or a pull. Now, remember, what is a push, class? What is a push? A push is when you move something away from you, move something away from the body. Or a pull. What is a pull? A pull is when you bring something closer to you. Okay, a pull is when you bring something closer to you or to your body. That is a force or a pull. Next, forces. There are many different forces which acts on objects. If forces are balanced, the object doesn't move. If forces are unbalanced, the object will do one of the following things. Oh, so there are actually many forces on the earth right now that we don't even see. And they are classified further into two things: balanced forces and unbalanced forces. Now, what will happen if the forces are unbalanced? Let's see. If the forces are unbalanced, the objects that have the force will begin to move, okay? They will slowly begin to move. Second, or if they are currently moving, they will stop moving. If they are currently moving, they will stop moving. Or they change direction, okay? If they don't begin to move or they stop moving, they change direction. Or if they are currently moving, they will move faster, okay? If they are currently moving right now and there's an unbalanced force, it means that they are moving a bit faster. Or if they are currently moving, they might actually slow down, okay? If they're currently moving, they might actually slow down. So if the forces are unbalanced, there's actually six things. There's six things. There's one that's not talked about, but I will talk about it after I explain each of them, okay? First is they begin to move. If an object is not moving and there's an unbalanced force applied to it, the object will slowly move. Let's say, for example, a soccer ball. If you kick a soccer ball, it will start moving. Or let's say that a soccer ball has been kicked. It's currently moving. You apply unbalanced force to it, it might actually stop. the movement. So it suddenly makes it slow until it suddenly stops, or it or sometimes if you have too much force, it might even change directions. That's right. It might even change directions. Or if the football or the soccer ball, it's currently moving and you kick it again on another kick, it will speed up. The speed of the ball will increase. At the same time, if you kick it far and your friend kicks it back to you, it will slow down the movement of the soccer ball. The last one is if there's an unbalanced force on an object, sometimes the object will change shape. Like, for example, a piece of paper. When I crumple a, let me find a piece of paper that I can use here. Okay, I have a piece of paper here. Let's say I crumple it. It will slowly change its shape. Here, much better. I crumple the piece of paper. It was a square, right? Now it's like a circle because I crumpled it. I apply unbalanced force to it. And that's the sixth thing. It might change the shape of the object. Let's go to the next one. Forces occur in pairs and they can either be balanced or unbalanced. So this is what I said before. Remember in my example, when you are playing football and you don't wear your football shoes, you don't wear anything, just kick the ball using your bare feet. You are the one kicking the ball. So why do you feel hurt sometimes when you kick the ball? And you are the one giving pressure or force to the ball, but you don't know the ball is also giving force or pressure to you. That's why the more you kick the ball, the more force it will have on your feet as well. Now, that's why they always occur in pairs. They can either be balanced or unbalanced. Now, what does balanced forces do? When two forces acting on an object are equal in size but are opposite in direction, we say the forces are balanced. Like, for example, force going down, a force going up. Balanced forces do not cause a change in motion. So what does this mean? When you and your friends are playing tug rope, you know that one, right? Oh, tug rope. One is pulling to the left and the other is pulling to the right. And they're not moving together. That means they have balanced forces because neither of the two teams are moving. That is an example of a balanced force. It will not cause any motion. I'm going to show you a force diagram on an object. In a force diagram, the force is shown with an arrow. The bigger the arrow, the larger the arrow, the bigger or larger the force. The arrows in a force diagram also show the direction that the force is acting on. Sometimes the arrow will be labeled with the size of the force in newtons. So here's an example. This one. If you look at it closely, the force going to the left is 100 newtons and the force going to the right is also 100 newtons. Can you see any difference between the two arrows? They are the same, right? That means that they have the same force. Now, let's see in the second diagram. The truck starts moving towards the right. Look at the bigger force, 100 newtons, and look at the smaller force, 60 newtons. Can you see how different they are? The arrow of the bigger force is much larger than the arrow in the smaller force. It becomes unbalanced and it forces the car or the truck to actually move towards the right. Here is another example of a balanced force. The ship is floating on the water. The forces are balanced. Which forces are acting on the ship? Oh, have you ever thought why the ship is floating on water? It's not like the ship is made of plastic. No, the ship is made of metal. And we know that metal is very heavy. However, people like us are very smart. They found a way to have balance forces on the ship, which allows the ship to actually float on top of water. And what are the forces that are acting on the ship? We have the first one is gravity. Yes, we have gravity. Second one is water or water's upthrust or the pressure that water applies to the boat. Remember, there are always two forces. First here is gravity. The second is the water's upthrust. Because gravity and upthrust are equal, the ship stays afloat. And that's it. Because the gravity is not strong, it's only equal with the water's upthrust. It allows the ship to actually float on top of water. I've actually thought about this a long time because before I was a teacher, I used to ride boats like this often. And when the water is very calm, the boat looks like it's not moving, but it is. It's moving forward, but it's still on top of the water. However, when there are strong winds, that's when the boat, while on top of the water, will start to sway because there are unbalanced forces. The unbalanced force is the strong wave of the water. Next example of balanced forces. The vase is resting on the table. It is not moving, therefore the forces must be balanced. Which forces are acting on the vase? If that's it, class, if something is not moving on a table, that doesn't mean that they have no force. No, it means there is a force, but the forces are actually balanced, meaning that it's not moving. It's in perfect limbo. So what is the force acting going down? I think you know what this is. This is gravity. Yes, exactly. And what is the opposite force? The table's up thrust or the force of the table to push up. They are in balance. Now let's look at unbalanced forces. When two forces are acting on an object and are not in equal size, we say the forces are unbalanced. Like, for example, the truck again. The truck will move to the direction on the right because the direction on the right is stronger than the direction on the left. The direction on the right is about 100 newtons, while the left is about 60 newtons. That's why it's going farther to the right. Unbalanced forces cause a change in motion by changing the object's speed or direction. And that is it for today. I hope you learned something new. Forces actually happens everywhere around us. If an object is not moving, that does not mean there are no forces acting on the object. There is. It's just that they are perfectly balanced. Let's say that the object has a force of 10 newtons force of gravity on the top of a table. The table is also giving 10 newtons force on the object. That makes it so that the object does not move. But what will happen if it has more gravity? Of course, the object and the top of the table will go down compared to the object at the bottom. Or what will happen if the table has more force than gravity? It will cause the object to actually go up, fly up, because it has more force. That is balanced and unbalanced forces. I hope you learned something new today. And I hope to see you again next time. Bye, everyone.